lines of fit. And so first of all, we're going to define what bivariate data is. And so real quick, if you break down the word bivariate, because I mean that's kind of a big word there. What does bi mean?
Two.
Two. Variate. When I think of a math word that sounds like variate, variable. So it means two variables. So data with two variables, that's what it means. Okay? And so we're going to talk specifically about scatter plots today. And scatter plots today, you can see those all over in magazines, in the newspaper, on the internet. A scatter plot is nothing more than a set of data graphed as ordered pairs. So when I think of it, I think of a scattering of points. Okay? It's used to investigate a relationship between two quantities. So if I look over here, the title of this graph is International Travel. What are the two quantities I'm looking at? The travelers per year, and what else? The specific year. And so what do I notice as I look at here with international travelers? What would be a conclusion? It what? Increases. So the later on that I get, or the closer to 2012 that I get, my international travelers are increasing, the amount of international travelers per year. Okay? And so that's just basic reading of graphs. And so today we're going to look at scatter plots. We're going to actually create scatter plots. We're going to look at this slide right here, which talks about positive correlation, negative correlation, and no correlation. I want you to look at positive correlation, and I just want you to tell me, what do you notice? It goes up. Positive correlation means something's going to increase. Okay? What about negative correlation? It goes down, it decreases. What about no correlation? It doesn't. It's just a random. It's just a scattering of plots. It doesn't go up, doesn't go down. It's just kind of a mess. Okay? So let's go ahead and look at the next slide. It says determine whether the graph shows a positive, negative, or no correlation. If there is a positive or negative correlation, describe its meaning in the situation. So what is this? Positive correlation. Okay? Now, I want you to make an interpretation from this graph. What do you notice is happening? Okay, so let's think about that. If I was going to add on more to the graph, what would happen? It'd keep going up. So, in conclusion, I can state that the more hours I work, the more money I make. Okay? So, the more hours you work, or the more hours worked, the more wages are made. And so it's really important that you understand how to read graphs, especially when you get to the ACT, because the science portion is huge on reading graphs, and they're huge on making inferences. Okay? And so it's one of those things that you'll see graphs a lot, and it's really important to kind of notice what are some trends, what does it look like the graph is doing. Okay, so let's go ahead and look at this. We're going to talk about a line of fit now. A line of fit is a line that best approximates a set of data. Okay, so on those scatter plots, when we have the smattering of points, all those points, if I were to draw a line in that's like exactly in the middle, okay, that's what the line of fit is. So there are 4 steps for a line of fit. The first one is to make a scatter plot. Determine whether any relationship exists. So that means, is it a positive correlation, negative correlation, or no correlation? Step 2, draw a line that seems to pass close to most of the data points. So basically, it's kind of like you're trying to average all those points. Find the line in the middle. Step 3, you're going to use 2 points on the line of fit to write an equation for the line. Okay, use 2 points. Why do I pick 2 points if I'm going to write an equation of a line? What's the first step when you write an equation of a line? Find the slope. So if I have 2 points, I can find the slope. And then step 4, we'll use the line of fit to make some predictions. Okay, so let's go ahead and look at this one. Okay, this is botulism. Okay, U.S. foodborne botulism cases. So very first step, we're going to make a scatter plot. So I'm going to start with 2001 and 39. So here's 2001, and 39 is going to be close to the top, but not quite at 40. So I'm going to put a dot. Then I'm going to go to 2002, 28. Once again, that's close to 30, but not quite there at 30. I'm going to go down a little bit more, probably about right there. 2003, 20. That one's an easy one. Okay, that's right there on the line. Next one, 2004, 16. So that's going to be just a little over halfway. And then the last one, 2005, 18. So what do you notice the trend is? It goes down, right. And that should make sense because botulism is actually like one of those, kind of like a food poisoning disease. Okay? And so it's one of those that, as the years increase, we're gradually getting better at safely handling food. So it's one of those things that, of course, it should go down. So now what we need to do is we need to find the line that best fits the data. And so the way to find the line that best fits the data is I'm going to go ahead, and you guys can use like the side of your calculator. Okay, something that's got kind of a straight edge. If you have a little ruler, that would work great too. But what I'm going to do is I'm going to find that line that if I put my ruler on, it looks like it just splits all of the data. Now, one of the things I'm going to give you a hint for, it's usually a good rule of thumb to try and have it go through exactly 2 specific points. Okay? It's usually a good rule of thumb to go through 2 specific points. Now, when I say 2 specific points, I don't mean 2 of the rainbow points. I mean like 2 of the points on the graph, like 2 points there. Okay, because that way it's going to be a lot easier for us to find the slope. So does that kind of look good? Does that kind of look kind of in the middle? Now, the thing about the line of fit is unless you have a calculator or a computer that does the mathematically best line, you could all have different answers and be all correct. Okay, so your answer here doesn't have to be the same as, you know, Christian's answer in the back. And that doesn't mean that you're wrong. Okay? So what I'm going to do is I'm just going to go ahead and draw this line in. Okay? And there we go. Now if I look 2 specific points that it goes through, I've got a point here, and I got a point here. So I want to find the equation of this line. So the first thing I'm going to do is find the slope. Okay, so to find the slope, I'm going to find the rise divided by the run. So what's the rise here going to be? Be careful. Negative what?
10.
Negative 10. Okay, you have to look at the y, and each one goes up by 10, so that's one of the things to keep in mind. What's the run going to be here? And be careful again.
4 years.
What's the run going to be? 2 years. Because I went from 2002 to 2004. Every one of those tick marks is half a year. So to find my slope, I'm going to take negative 10 divided by 2, which is negative 5. So now, if we remember, I've got my slope. So the very first thing I'm going to do is go to slope-intercept form. So y equals negative 5x plus b. Now I need to find a particular point that line goes through. So to find a particular point, I'm going to pick either the first point or the second point. Doesn't matter which one. I'm just going to pick the first. The coordinates of that point are 2002, what? 30. So that means I'm going to plug in what for x? 2002. What am I going to plug in for y? 30. So I've got 30 equals negative 5 times 2002 plus b. So what is negative 5 times 2002? Negative 10,010. So what are you going to do to solve that? Add 10,010 to both sides. Good. And you get b to equal 10,040. So what is my final equation going to look like?
Y equals -5x plus 10,030.
Perfect. Good job. Y equals -5x plus 10,040. So now what that means, if I were to ask you, in 2012, how many botulism cases would we have? In 2012, how many botulism cases would we have? Let's think about that. Okay? 2012, would that go on the Y or the X? It'd go on the X, right? Because 2012 would be somewhere out here that you can't see in the video. Okay, so if that's an X, all I have to do is go back in here to my equation and take -5 times 2012 and add 10,040 to that. That's all you would have to do. And then that should tell you how many cases you're going to have. And in fact, this doesn't work because this is actually going to be a negative. Okay? But that's what you would do on your homework for today. Okay, questions? Alrighty. You have numbers 4 through 10 on pages 250 and 251. Now, if you work really hard, you should be able to get the majority of it done. Okay, so you might not even have to take it home tonight. Okay, so page 250, 251, 4 through 10.